So let's look at a few more problems for determining the congruence of two triangles, which are a little bit more challenging. And remember the different congruence relations. We have side, 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 angle, side, angle, 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 side, and hypotenuse leg, which remember is just a special case of side, side, angle where the angle is 90 degrees. And if we have any of these five relationships, then we know the two triangles are congruent, meaning they have the same shape and the same size. Now, looking at this specific example, these two triangles, we can notice they share a set of equal sides. And we can also notice they share an equal angle. But we don't know about anything else at this point. But since we are told two of the angles in each of these triangles, what we can do is figure out the third angle and then see if our information matches up with any of these rules here. And remember that the angles in a triangle add up to 180 degrees, which means if we call this x, let me use a different color, then we can make an equation where we add these three together and set them equal to 180. Which means we have 67 degrees plus 65 degrees plus x is 180. And if we solve this for x, then x is equal to 48 degrees. And we can do the same thing over here. We can call this angle here y and say that 48 degrees plus 65 degrees plus y is 180. And solve for y. And when you do that, when you add these together and subtract them from 180, you do find that y is 67 degrees. And if we mark that in here, this is 67. And that means that this angle here and this angle here, these are the same angle. They are equal to each other. And also, if we want to mark this in, this angle here and this angle here, since x is 48 degrees, these are equal as well. And now notice that we have two correspondingly equal angles and we have a side length, a set of side lengths that are equal as well. And if we compare it to one of these rules, we have angle, side, angle. And the same over here, angle, side, angle. Which means we can use the rule, this ASA, angle, side, angle, to prove that these two triangles are in fact congruent. And remember, that just means that this side length here between the orange and green angle is equal to this one here. And likewise, this angle or this side length here between the green and pink angles is equal to this one over here. They correspond to each other. So are these two triangles congruent? In this case, yes, they are. And let's do another problem. And for this one, we again have these two triangles, and we can notice that they share three sets of equal angles. Since we have a 37 in both, we have an 85-degree angle in both, and lastly, we have a 58-degree angle in both. Now, it is possible that these two triangles are congruent. We have the angle, angle, angle relationship. But remember, when all of the angles in a triangle are equal, this doesn't necessarily imply that the triangles are the same size. But we do have a word for these triangles, these shapes that have all the same angles. We call these similar. But what can happen is that if you start with one of these triangles, you can scale it, either make it much larger or much smaller, and it would retain this relationship where all of the angles are still equal. They correspond to the other triangle. But at that point, the size will be much different. And you can imagine this if you drew a smaller version of this triangle on the inside. And this won't be drawn perfectly, but you can imagine this is 37, this is 85, and this is 58. The angles correspond to the angles in this triangle, but it's much smaller. And so therefore, we don't have enough information here. Like I mentioned, these two triangles could be congruent. They do look like they're congruent, but we can't assume that the triangles are drawn perfectly. And therefore, when we solve a problem like this, we really just have to conclude that we don't have enough information. Maybe it is, and maybe it isn't. We need more information about the side lengths. If we knew that maybe this side here and this side here, that these were equal, then we would know for sure that these are congruent triangles, since we'd have angle, side, angle for both of these. But we don't know that. So we don't want to make any assumptions about the side lengths. Now let's look at one final example. And this last one is tricky. We have these two triangles where we know that they share a set of equal angles, and they share two sets of equal side lengths. And if we wrote this out, this would be side, side, angle, or angle, side, side, though it's usually not written that way, as you can imagine. And if we have side, side, angle, it's possible that these two triangles are congruent. But we don't know about this angle here. If this angle was 90 degrees, then we would have the special case where this is the hypotenuse leg, and since it's a right triangle, then we would know that the two triangles are congruent. We can use the Pythagorean theorem to find the third side length, and then we would have side, side, side. But we don't have that information. And since we don't know enough about this angle, and because we have side, side, angle, we can conclude that we just don't have enough information here. So our answer would be not enough information. And the takeaway is that these triangles could be congruent, since they do look congruent, but remember, the triangles aren't drawn to scale. So they could be congruent, but they might also not be congruent. And it's basically because we don't know enough about this angle, which means that there are two different ways to orient this line. And in this problem, this actually almost looks like a 90-degree angle, but we don't have that information. So if we assume that this is greater than 90 degrees, then the other way to draw the triangle would be to have the angle less than 90 degrees down here. And you can imagine this being extended here. And therefore, there are two different ways to draw that. And if this was more extreme, like significantly less than or greater than 90 degrees, then it might be a little bit clearer to see that. Maybe something like that and something like that, where you can have two different ways to draw that triangle. But if this we knew was exactly 90 degrees, then we would know the two triangles are congruent. But again, the conclusion, are the two triangles congruent? We simply don't have enough information.